Okay, we're going to be working with similar triangles in this question. I've drawn two similar triangles, or at least they look similar. In order for triangles to actually be similar triangles, their angles all have to be identical, the exact same. Okay, so I'm going to make up some values here. We're going to say that this is, I don't know, 60. This will be 40. And this will be 80. They're not perfectly to scale, okay? Which means in order for this to be a similar triangle, this must be 60, this must be 80, and this must be 40. Okay? Now what I'm going to do is I'm going to make up some values for this triangle. This may be an impossible triangle. I'm just picking values out of our head so that I can show you the process to finding the other similar triangle. So let's just say that this is maybe 12, 5, and 8. Okay, again, this is probably an impossible triangle. That's probably not true. But what I do want you guys to recognize here is that the value of this side here is maybe 2, or the distance of that is 2. So what we're going to be able to do with this information, because the angles are all identical between the two triangles, it's okay, you can go across. Okay? Because they're all identical, what we're going to be doing is we got to find the scale factor between these two sides. Okay? So, if this is -2 and this is 8, what operation did I do to go from the 8 to the 2?
Divide by 4.
We're going to divide by the value of 4. So since that's true, because these are identical triangles, 8 divided by 4 will get us to 2. That's going to be our scale factor here. So in other words, to figure out what the measure of this side is, we need to get the corresponding side, that is this one here, and we need to divide it by 4 to figure out what the length of this side is. Anyone know what that's going to be? That's right, 1.25. So the measure of this will be 1.25. Okay. And again, I know it's not to scale. And then finally, we'll have to do the same thing with 12. What will 12 divided by 4 give us? That's right. So that means this side of this triangle is 3. Now let's say that I didn't actually have the measurements of the larger triangle. I only had the smaller one. Okay? That's right. It is a bit easier. I would know to go from 2 to 8, what operation would we use? Multiplication by the same scale factor of 4. Okay? In other words, if I had this, I'd multiply that by 4 to get to our 5. And I'd multiply 3 by 4 to get to our 12. That's right. It's a little easier to go from a smaller one to a big one. But what's very important is our scale factor. Okay? Our scale factor pretty much has the same value. What changes is the operation. Whether we're multiplying or dividing is what we have to figure out. And in order to be similar triangle, again, the angles all have to be the same. It doesn't have to be right angle, anything like that. They just have to have identical angles.